Our next keynote speech focuses on the climate crisis and the future of energy, with Dr. Gregor Hagedorn, who, after studying biology, received an interdisciplinary doctorate in biology and computer science at the University of Beirut. He's worked at the Museum für Naturkunde in Berlin since 2013, researching data infrastructure for the protection of biodiversity and looking at the fundamental questions of how to solve the sustainability crisis. In February 2019, Gregor initiated the Scientists for Future movement. Thanks very much for joining us today, Gregor. He will be joining us in just 1 minute. Until then, here he is.
Hello.
Hello, Gregor. Now, if you could share your presentation on the climate crisis and the future of energy.
Should I start the presentation now?
Yes, please. That would be great.
Okay. I was just instructed not to do so. That's why I'm asking back. I will do. So, welcome everyone. My presentation is about the climate crisis and future of energy. You have already heard a lot from my colleague Stefan before this talk, and I'm trying to elaborate on some points about what to expect for the next years. Where are we going? We all agree that climate change is real. This is like the current most temperature gradient that we see, and we see that there's a lot of variation in there, but it's undoubtedly, as you have seen in Stefan's talk, a great lot going on. But the question is, why did we fail to act? And it could be that we didn't know, that we didn't have good predictions. I doubt that. Here is an example from Exxon, the oil drilling company from 1982. And it is about the CO2 greenhouse effect, not to be distributed externally, the study. And it contains this graph. We can look at this graph, and it's a little bit complicated, so I will elaborate it. We are here in the year 2021. So on the upper graph, the CO2 is plotted, and we see the estimate in 1982, almost 40 years ago, by an oil drilling company, was that we would have 420, a little bit above 420 ppm CO2 concentration. And yes, almost point on. In May 28, we had 420 ppm this year. The other curve is about the temperature. And it's estimating something of a temperature increase of about 1.0 degree. It's rather higher at the moment, rather 1.1 or even 1.2, going towards 1.2, depending on the baseline and all this. But again, this prediction wasn't terribly wrong. I would say it's excellent work. So if we look at the current most, this is really like up to the 2 weeks ago, the current most atmospheric CO2 concentrations, and we plot in the 1982, we see we did a lot of nothing since then. We talked about it, but we didn't act. We had no real impact on this increase of the CO2 concentration line. In fact, it is still slightly increasing. It's bent. It's not a linear shape. It's an upwards bent shape. And it is hard to say what actually the acceptable concentration of CO2 is, but it may be as low as 350 ppm, which would mean that the whole area shaded here in light red would be CO2 that has to be removed by our children and grandchildren again. So it's not really, we talk about a budget, we talk about a CO2 budget of things that would sort of make it possible to steer the curve once including these removals, but really we are in CO2 overshoot. So instead of acting, we had other predictions. This is a nice example by the International Energy Agency the energy outlook. And it first shows in this dark black line here the actual solar capacity added each year, the line of the solar capacity. And you also see all these colored graphs, and you see from which year are they. So Auke here had this fun idea of plotting for each year the predictions of the EAA for each year new. So you can see the first year they predicted, well, it's going to be flat. Okay, at some point in around 2010, well, the actual reality was widely off their predictions, but they still predicted it to be rather flat. And they continued year after year after year. So actually, the International Energy Agency got it 14 times wrong, and that's quite impressive. And these aren't stupid people, but they kind of didn't leave their mindset, and they were unable to be corrected by reality. So that may be a reason that we didn't act, because we had false predictions. What happened really? We also have very many stories, especially in entrepreneur circles, about how brilliant the future will be, how effortless the future will be. And there's a lot to it. This is a graph that we might see there. It's the graph of the global renewable energy progress. You see dark blue is water, light blue wind, green bioenergy, and yellow solar capacity. And they're all really nicely increasing. It almost looks like an exponential curve, which gives hope. The problem is that on the right side now, I present the same graph. It is the same data, except that the red line shows the global energy use. And we see global energy use is increasing. And it isn't just increasing because we in the rich countries, we are doing stupid things and buying totally useless consumption items, or it is in part because we are consuming, but it isn't only because of that. It is because much of the global planet is catching up. It is catching up with our lifestyle. And catching up with their lifestyle may mean doing things that aren't ideal, but it also means that children in some countries have a chance to learn at all because there is a single LED lighting in their house driven by a solar capacity, by a solar panel. So it is not that renewable energy strategy is wrong. The problem is that we have been confusing progress with success. Progress is not success. If you're making progress in school, in your studies, it doesn't mean that you will pass the examinations. Progress is progress, sufficient or insufficient progress. And this green line that I'm showing here would have been the path of the renewable energy build-up that we should have taken. I think a good image is like if I had cancer and I go to a physician and the physician tells me that, yes, that's a pretty dire situation, but we do have a medication for it. And taking this medication at these prescribed doses would mean you get healthy again. And then I somehow say, well, actually, that's quite expensive. And also it has some side effects. So, well, yes, I'll take that medication, but I'll only take a 10th or 20th of the necessary dose. This is almost what we have been doing in the past 40 years. We have taken way too little doses, and we have taken small doses that were insufficient. Change was insufficient. Change of imagination and predictions were worse than infrastructure change. It is understandable that many people associate change with risk. This is our experience. When something is changing, it is hard to predict. We often have personal experiences that some change was detrimental, that change wasn't like the good thing that happened to us, but maybe we lost a job and had trouble finding a new one. We may have pet parents that went into unemployment, etc. But in reality, there's two things here. There's a risk of no change, a risk of staying the same, and a risk of change. And reality, we balance each other. So when we talk about change, we need to talk about risk. We need to realize that risk realizing the risk of no change may mean change, may motivate people to change. So as a short introduction, it doesn't matter so much what I'm thinking, but it is quite interesting what almost 800 experts from all fields, many of them working in insurance companies, many working in investment, many working in technology, in digital technology, etc., are thinking about the risk of climate change here. And the World Economic Forum each year is running this global risk assessment. And it doesn't ask the experts, the almost 800 experts, it doesn't ask them that just how risky do you assess it. It actually splits risk down into these two axes. So risk has something to do with how impactful is when it happens. So when it occurs, how bad is it? Will you just have a broken bone, or will you be dead because something happened to you? And the other thing is, how probable is it? How likely is it that it will occur? And you see here all the events, all the possible events the World Economic Forum has asked about. And the important thing here is not to read all of them, but just to see they come from a broad diversity of fields. They come from social fields, they come from digital fields, from financing fields, from governance fields, all things. The green ones come from the natural resource agenda. And for example, as an example, on the left side, you see weapons of mass destruction, which means global atomic war, as we would usually call it. So the probability of this occurring is really low, not because we are lucky, but because so many people are working so hard to make this probability so low. And the impact would be catastrophe, a global atomic war. And here on the right side, the things I'm just circling, you see everything that has something to do directly or indirectly with climate change. And you realize, wow, I mean, these circles, so many of them are in this uncomfortable area of high impact with high probability. And in fact, failure to address climate change and loss of biodiversity, we can just focus on the climate change here. And we see that if we ignore the risk, so if we ignore the probability, if we ignore the fact that this is estimated, not proven to be, estimated as a highly probable event, if we ignore that and just look on the impact axis, it shows that the experts are assessing the impact of failing to address climate change as being worse than a global atomic war. This is a huge thing. This is the interesting thing about this is not that some people think that, but that a large group of experts comes to this conclusion, and we, as a large society, are living in kind of blissful ignorance. Most people in Germany agree that climate change is a big issue, but again, most people in Germany vastly underestimate the impact of failing to address this problem. Most people would probably end their likelihood how hard that problem is, how important that problem is, as something on the level of how do we store the nuclear waste for long term, which is probably an order of magnitude too small. So it is not the pseudo-scientific phony arguments of climate deniers that we are up against. It is the general tendency to not really appreciate the risk, the level of risk we are taking, we as decision makers are taking, and which our children and grandchildren will have to live with. This is a good symbolic image for this. You see a large forest fire, and you see people, well, just watch it a little bit. That looks interesting. Or maybe just continue to play golf. And probably many of you are thinking this is a photoshopped image. It isn't. This is the thing about this image. This is a real image with real people. The location is known, the date is known, the photographer is known. This is how we humans might react to such an event of such a big forest fire. We need to get out of this. I have great optimism that change is coming. not the least the recent German National Court of Constitution, what they said. So I think voters are waking up, politicians are waking up, judges are waking up, investors are waking up, businesses are waking up. We need to focus on needs, not possibilities. Greta Thunberg said, until you start focusing on what needs to be done rather than what is politically possible, there is no hope. If solutions within the systems are so impossible to find, then maybe we should change the system itself. I think people are realizing that the risk of no change is much bigger than the risk of change. And building on that, we can do new predictions. We can do new predictions of the future. There is this is a nice graph, and you see here a variety of technologies, and all these things are not on a real yearly base, but it is the years after reaching 20% adoption. And we could make, if we had time, it is fun to think about what you think might be on there. Yes, the computer and the internet are in there, but there's also a lot of other things which probably I wouldn't have thought that they follow the same pattern of technology adoption. You have the refrigerator in there. You have the microwave in there. You have lots of technologies that all, like after reaching 20%, have almost reached saturation and have in 20 years and have reached saturation in 30 years. So my message, like many of you to you, is don't fool yourself. Don't take your predictions on the past. The next 20 years are likely to be very interesting. As scientists for future, we have recently published a paper called Klimaverträgliche Energieversorgung für Deutschland, 16 Orientierungspunkte. Unfortunately, only the introduction is translated so far, but it may be of interest to some of the listeners here. And one of the things is we need to focus on renewable energy. Unless we increase the yearly increase in wind power by a factor of 3 and of PV by a factor of 6, we won't reach our climate goals. Some very few points here. So PV and wind are going up strongly. And quite interesting, lack of labor is probably the biggest problem that we have. We need to anticipate that. That is something we need to do, invest a lot of effort into to make it not the bottleneck. For this reason, amongst others, roof PV probably won't be as much contributing as we would hope, because roof PV is kind of perfect also from a general standpoint of biodiversity protection, but solar parks will play a much stronger role than anticipated before. Agri-PV and maybe polluti PV, we have a lot of organic soils which we need to wet again so that they're not emitting CO2. We can build solar there. Battery storage, vehicle to grid, H2 storage, power lines, you probably all know this. The interesting thing I learned personally about the power lines is actually that the power lines are less working well if you look at the long time wind and PV lulls, because they are often EU-wide, and the power lines help a great deal for the 1 or 2 day spell, but they don't help as much for the 7-day spell. So we need to have more local backup electricity generators than we need to have long line power lines. Bioenergy is probably going down. It's a very inefficient way of using an available area of land, whereas biomaterials will be needed much more. So it's not really that we can free up all this agricultural space, but bioenergy is not the best use for it. H2 imports, we all can discuss that, but I think we need to realize that iron and ammoniac imports are probably coming first. They are highly energy-dense materials that we need. And especially for gridX here, I think private solution for rich people, that is you and me, and probably all that are listening here, are going down. We need societal solutions. We can't solve it like with this mental image of the very rich person who owns the private house, who has a very large roof, who is occupying way too much space than can be justified, and who has the money in the bank to build everything for herself or himself. We need societal solutions, and yes, the locality is very important. gridX focusing on locality solutions is important, but it is not, the future is not about the in-house locality solutions of the very rich. It is about the regional locality solutions, maybe as low as a whole neighborhood. And in reality, of course, we need to talk about sustainability, agriculture, food, soil, land use, social justice, security, all this. Personally, I'm a biodiversity expert. I think the COVID crisis is overshadowed by the climate crisis vastly, but the biodiversity crisis in retrospect probably will be seen even as worse. We need to look at all these crises in a context of sustainability. And we need to stop gobbling about which is the best solution. The solutions is that we need to push all channels on max. We need to push the channels all to our utmost possibilities. And if we do this, I'm quite optimistic. I'm quite optimistic that we can change our thinking, that we can start a new thinking, that we can be very active, that we don't need to base our estimations on the future, on the past 50 years of slow change, that we can enter an era of very fast change. And when we are doing this, I think in the year 2050, there will be a great General Assembly of the United Nations, and the General Secretary of the United Nations, she or he, will say perhaps something like the following: it is hard to believe that what would now be a crime against humanity was legal at the time in the 2020s. I think if we look at our current world with this in mind, with the mind that we may look in 30 years back on our current realities, like we are looking back on the realities of a country that finds slavery totally normal and not a crime against humanity, I think we can change our world. Thank you very much.
Thank you very much, Gregor. We've had a few questions come from the audience during that very interesting discussion. And the first is, what is the link between digital transformation and global warming from your perspective?
I think digital transformation is a transformation that, like many transformation, whether it's battery technologies, digital technologies, it's all in our tool set. It's part of our tool set. It's part of change. We see it is driving change, but digital technology is consuming resources, and it has the potential to contribute to the solution of the problem. It will not contribute to the solution of the problem if we don't make it to. You can use digital technology like probably most technologies in any directions. You can make the world less sustainable with it, or you can make it more sustainable. It is part of the tool set, and I think as such, it is a very important part of the tool set, but it won't be by any means the savior. It has a relatively minor impact if you compare it with the problems as a whole. If you compare it with the problem of heating, of building, with the problem of the energy sector, with the problem of the food sector and agriculture, it probably comes after these sectors.
Mm-hmm. And is it useful to talk about individual responsibility, or should we focus on systemic collaborative change?
I think we need to focus on both. We need to focus, we can only solve it as a society. But if we sort of don't stop trying to solve it to make our own contributions to it, we cannot learn. If we don't speak with our friends, if we don't speak with our neighbors, if we don't build local alliances about how the world should be, we cannot solve it. We are living in a democracy. We need to take our society with us. So probably the most important thing is not to do things silently at home, to secretly buy something else, to secretly change your finances and investment to something that is greener. The most important thing about changing your personal private lifestyle is about talking with your friends and neighbors about it, why you do it, convince them to maybe change their thinking, and then we have alliances that will change our society.
Mm-hmm. And where do you think the biggest mismatches are on what dominates the conversation and what the biggest problems really are?
I think, as I said, I think one of the biggest mismatches is the risk assessment. It is not the assessment whether climate change is real or whether it exists. There are people that are denying it. You can always find these minorities for any question you ask. But the majority opinion, and I'm afraid we can see it in the party programs for the next federal elections in Germany right now. The parties don't believe that their voters have really take climate change as a serious risk that needs to be addressed, just like something like a military threat by another country. It's an existential threat to our society. It's not about survival of us as humans. We as humans will survive. But in which kind of society we can survive, that is really at stake.
And a viewer asked, could you elaborate on why you think solar parks are more effective than solar rooftops?
Labor shortage. We need an awful amount of energy. We actually do calculate the energy efficiencies, so there will be some relatively easy gains from changing to electrification in terms of energy efficiencies. We also think that we need to change our lifestyle and will gain a reduction in energy loss, in energy use from that. But even assuming these changes, we have to realize how much renewable energy we need to install to keep our society running. And this is so much, and we have wasted so much time. This is really true. I mean, we have wasted at least the last 15 years. We've probably wasted more. And we need to catch up. So we need to be fast. And you can't be fast with the optimal solution that takes a lot of highly qualified labor and is very labor intensive if you don't have the labor to install on rooftops. I think we will continue to install on rooftops, and we should do it. But we should also realize that there is no chance of installing enough solar capacity on rooftops. So we need to prioritize land-based solutions. And we need to prioritize those solutions that don't conflict with food production and don't conflict with biodiversity preservation. And there are lots of opportunities to do that.
Mm-hmm. And earlier you talked about false predictions in the past. Is there a chance that our predictions currently are false?
Of course. It could be false, but it's a question of probabilities. So for which future do you want to prepare? Which risks are you going to take? So if you're happy to, I have this image of you live in your house on one side of the motorway and the school of your children is on the other side of the motorway. And you could either drive them around a long time, or you could just say, well, just run over the street, look left and right. There won't be a car coming, and then you're at school in 5 minutes. Well, which risks would you take for your children? Would it be enough that with 95% probability they survive their school time? No, it wouldn't be. But, our climate predictions have a 50% probability that we might make it. So we are very happy of gobbling about whether, we might make it with a 50% probability if we do it slightly slower. We need to speed up. We need to realize that maybe the predictions are too pessimistic, but maybe they are too optimistic. We don't know. And we need to have some safety margin. So as a society, I wish our societies are playing with a safety margin rather than to go to the extreme of intolerable risks for the future of our children.
And you mentioned before there's a lot of factors we need to take into account: food production, biodiversity, energy. How can we increase dialogue and collaboration between all of these different parties and also involve end users, governments, to ensure that we're on the same sustainable path and we really achieve carbon neutrality?
I think there are many great examples of where that is happening all around the world, in Germany. The problem is, of course, that if we are specialists in one area, we need to focus all our energy on that specialty field. So if all of you are making some time free to connect with other groups, then we have this time. There are many initiatives that try to integrate that. In Germany, we have several excellent councils, the WBGU, the SRU, who are purposely interdisciplinary and bring these things together. There are many initiatives. We, as Scientists for Future, are among one of them. As Scientists for Future, probably our greatest work is to understand each other, to talk with each other across the disciplines and try to bring different people together. I can say even with this energy paper which we have produced, there were interesting discussions while producing this oversight paper with the 16 orientation points among different specializations which learned from each other. We should have many of these opportunities. We need to use them.
Thank you so much, Gregor. It's a very interesting discussion. Unfortunately, we're out of time now, so we will be moving on to our next speaker, but thanks again and have a great afternoon.